Hello student. In today's session, we start chapter number 13, AC circuits. So in previous standard also you already learn electricity are of two kinds, means DC electricity and AC electricity. So basically DC current means what? DC current means direct current which have a fixed polarity. And AC current, it is called as alternating current. Alternating current यानी which don't have fixed polarity. Its polarity reverses after every half cycle. So it is alternating current. Take it, that you already learned in the previous standard. As well as you learn AC generator in the last chapter. So in AC generator, in AC generator, so when the coil is rotated in a magnetic field, then alternating EMF is produced, alternating current is produced, and it is given by formula E is equal to E0 sine omega t. This is equation number 1. So this is EMF produced. This is the alternating EMF. If we plot a graph of this, then we get this type of graph. This is the sine term. So if I taken on this axis, this is omega t, and here the maximum value and the minimum value, maximum plus E0 and minimum minus E0. So here it is, sorry, maximum E plus E0 or minus E0. These are the maximum values on opposite sides of G. This is 0. Then we get this type of graph. So this is alternating EMF. Similarly, we can write alternating current also I0 sine omega t. If this EMF and current having a same phase, we can write sine omega t. But if between the EMF and the current some phase difference is there, then I can write here plus minus that phase difference. I can write here plus for sake of the convenience, but plus minus. It depends the current is leading with that phase or current is lagging. Based on that plus minus we can write. Take it. Now here, if you want to measure such EMF, such current, we cannot use a normal voltmeter, normal ammeter, because the normal voltmeter gives us the average value, and average value of this EMF is coming 0. You can see a graph here. So here EMF is positive, here it is negative. So this positive and this negative cancel with each other, and we are getting average 0 over one cycle. So for one cycle, the average of this alternating EMF, alternating current is coming 0. Now here, let me define here the average and the RMS value, average value and RMS value. Now here, so when we are talking about the average of current, average of this EMF, then we have to find out average of this sine omega t or sine of this angle. So basically, so instead of finding average over a cycle, you know that average over a cycle is coming 0, we can consider half cycle only, 0 to pi only. So here it is a 2 pi. Instead of 0 to 2 pi, we consider 0 to pi only. And we find out the average of this sine omega t. So average of this sine theta over a half cycle is given by formula, this 0 to pi, this sine theta d theta divided by 0 to pi d theta. By this formula we get the average. Now here, integration of sine theta d theta is how much? Sine, it is coming cos, minus cos theta, and the limits are 0 and pi. So here integration of d theta is coming theta, and if we substitute the limit we get pi. So we get this formula here. Then after that, the next one is, we can write sine theta average is equal to, so if I substitute the limits, so we get here minus cos pi minus plus cos 0 divided by pi. So cos pi is minus 1, and because of this minus, or I can write it here minus of -1 plus 1 divided by pi. So it is coming 2 upon pi. So 2 upon pi means, so it is coming 0.636, recurring 6 is coming, I think, so 7. So this is the average of sine theta. Hence, we can write here, we can write the average value of EMF. I will write it here. Hence, average EMF is, so EMF is given by this formula. If you want to write average of this sine omega t or sine theta is coming 0.637, and this peak value of EMF is as it is. So 0.637 E0. So this is the formula we get for average EMF. This is the average EMF. Okay, also average current. Instead of writing here, I will write it here. Average current is I is equal to 0.637 I0. So here I0, E0, these are the peak value of current and EMF. Peak value of current, peak value of the EMF. So I hope everyone understood this, what is average value and what is average value over a half cycle. You remember here. So this average value of EMF is 0.637 of peak value, means we are getting average here. So we are getting average at this point. So average is less than this peak value. Similarly, we can obtain RMS value of the EMF as well as RMS value of the current also. Now, RMS value of EMF and current. Now pay attention. RMS value of the current, let me discuss. The RMS value of the current is the steady current. It is steady current which when which when flows through resistor produces same amount of heat produced by AC करंट. अगर एक AC करंट हमने रजिस्टर में से पास किया एक पर्टिकुलर टाइम के लिए और उसने एक अमाउंट ऑफ हीट प्रोड्यूस की, तो उतनी ही हीट जो करंट स्टेडी करंट प्रोड्यूस करेगा उसे हम बोलेंगे RMS करंट. RMS value of the current is the steady current which produces same quantity of heat which is produced by the AC current. अभी यहाँ पे RMS value of the current and RMS value of EMF obtain करेंगे. इसकी जरूरत क्यों है? Because you know that moving coil devices, moving coil means basically normal moving coil voltmeter, moving coil ammeter, it measures the average value and average value of the current is coming 0. Then to measure this current, we can use another property which is direction independent. So we can use a heating effect. So you know that Joule's law of heating. So heat produced in a conductor directly proportional to this I square RT, or we can write H is equal to I square RT. So this is the heat produced in a conductor. So heat produced in a conductor depends on current, resistance and the time. So here, let me find out here the average current. So average current we find out by using this formula. Hence, average of this current is equal to, so integration, we are finding over a complete cycle here. So average current over a complete cycle. So 0 to 2 pi I square d theta divided by 0 to 2 pi d theta. Now here we have to solve this one, but here I is equal to how much? So here before that, so it is coming 2 pi, so this lower term, so 1 upon 2 pi I can take it outside, so 0 to 2 pi I square d theta. Now here 1 upon 2 pi as it is, this 0 to 2 pi integration I, you know that I is equal to I0 sine omega t, or I can use I0 sine, instead of omega t I can write theta. Then I will get here I0 square sine square theta d theta. We get this. Now I square also we can take outside, I0 square divided by 2 pi, then integration 0 to 2 pi sine square theta I can write 1 minus cos 2 theta divided by 2 into this d theta. Now we can separate this integration and we can solve it. Then we get, so this 2 also we can take it out, otherwise I will write it here. So average value of this current or RMS current is equal to I0 square divided by 2 pi into this 2 also we can take it outside. Then in a bracket, this integration 0 to 2 pi d theta minus this integration 0 to 2 pi cos 2 theta d theta. Now here, so I0 square by 2 pi into this 2. Now this integration is coming 2 pi and this is coming 0. So here we can write it here, I0 square divided by this 2 pi and this 2 pi get cancelled, divide by 2. So this is I RMS square. So I RMS I can write I0 divided by root 2. So this is the root mean square value of the current. So 1 by root 2, root 2 होता है 1.414, or I can write it like this way, I0 divided by 1.414 I think, or 1 upon this root 2 or 1 upon this is coming 0.7071 I0. So in that way also we can write, or also we can write similar manner, ERMS is equal to E0 by root 2, or we can write 0.707 E0. In that way also we can write. So here average value of the current we are getting 0.637 I0 and RMS value is coming 0.707 I0. Means this RMS value is greater than the average value.